Hi friends, in this video series, we are developing and deploying AI agents on different services from AWS, GCP and Azure. In the first video, we built an AI agent which enabled the customers inquire about their order status in natural language. And in the second video, we wrap the AI agent in a FastAPI application so that the client apps can make HTTP requests to interact with the agent. Alright, so this is the third video. Today we containerize the application so that from next video we can take the container and deploy it on different services from GCP, AWS and Azure. Alright, but why do we even need to containerize the application? Okay, so let's go over some concepts before we delve into the code. Alright, okay, now here we have our application code, right? It's a bunch of Python files, requirement files, database files, etc., etc. All right, what do we need to run this application? One, the application code itself, and the application is run using a bunch of frameworks, right? For example, it might be a Python, JavaScript, etc., etc. And also we might be using a bunch of libraries, like for example, FastAPI to create the endpoints, database, SQL Alchemy, etc., to connect to the database, some other bunch of libraries. And then for the framework to run, we need OS. Okay, so we need three things. Of course, the hardware also, but to run any application, we need the application code itself and the framework, sometimes also called runtime. This can be Python, JavaScript, etc., and the dependencies, which we call the libraries, and some operating system. Okay, so these are the three things required. Now I can take this code to some cloud service, but I need to create exactly the same environment, the same Python version, the same libraries version, and also the OS version. So I need to replicate exactly the same environment so that my application runs smoothly, because this application is developed in a particular environment with particular frameworks, libraries, etc. Right? Now, if I want to deploy the application elsewhere, I need to repeat exactly the same process. Now, instead of shipping just the code, what if we package these three things together and ship that package? Okay, then that package can be deployed anywhere we want, right? So the packaging of application code, the frameworks and OS, okay, these three together is called containerizing our application, which makes it easier to ship the containers and to deploy them anywhere we want. Okay, so you might have seen images like these on the internet when we talk about Docker. So here we have the infrastructure. In my case, it's this Mac laptop, and then we have host operating system, which is iOS, and then I have installed this Docker engine. Okay, it looks like this, and then here we have the application. So here we have three different applications. Now these might be using different frameworks, Python, JavaScript, and etc., etc. They might be, one might be web application, other might be something else, etc., etc. Right? So when we containerize, it has three things. One, our application code itself, and the second, these frameworks and libraries. Now you might ask, where is this operating system? Now the operating system largely consists of the kernel plus some OS related this bin and lib files you typically see in /bin and /lib folders in Linux based operating systems. Now when we have these containers, they have a much lighter version of OS. The reason is we still leverage the host operating system kernel. Okay, we want to keep these containers self-sufficient, but at the same time very lightweight. Okay, so that we can easily transfer and quickly deploy. Okay, so what we do is we still leverage the host operating system kernel, which is what the bulk of operating system, but we include only the missing parts like the lib and bin files are related to that operating system. Okay, so that's why the third component is not explicitly mentioned here, but these are the three things we need to run an application, and we containerize them so that they can be hosted and run anywhere. Okay, that's the idea of containerization. All right, so within Docker, we have these three concepts: image, container, and engine. Sometimes the image and container are used interchangeably. That's okay, but there is a clear distinction between them. So the image tells what to build. Okay, it's sort of this blueprint. Okay, so the image simply has the application code, what frameworks we are using, the libraries, the OS version, etc. So it contains all the information we require, but nothing has been done yet, nothing has been built yet. Okay, it is just what to build. The container is the running app. So once we execute, let's say, the image, we run the application, right? So that is called the running of app is called container, which is the built thing. Okay, the built thing. All right. Now, in order to create these images and containers, we need a tool/engine, which is what we call this Docker engine. Okay. All right. So what does the Docker file contain? As we just discussed, it contains the 4 pieces of information, broadly 4 pieces of information. So the first one is what operating system we need. So it goes from the lower to a higher order or more granular. So we start with this operating system, and then we have all the libraries and the frameworks in the second step, and in the third step we have the application code, and finally we have instructions on how to run the application. Okay, so let's look at now. To create a Docker image, we have a Docker file. Okay, sorry, there is a typo. Okay, so this is how it looks like. Here is an example of Docker file. So as we discussed, to begin with, we have an operating system. Now this one, as we discussed, it's a very lightweight OS. Okay, so it doesn't contain the kernel. It only contains the OS related libraries and bin files. So that's why this one is typically a couple of 100 megabytes only. Okay, it's not a full-fledged OS. All right, and then this one is optional. So again, as we discussed, we want to keep the container as lightweight as possible, right? So whenever we run a Python application, it creates that PyCache files, right? So we don't want to write those files. So what we are saying is, Python, don't write bytecode. So the bytecode means the cache files. Okay, so we don't want to create cache files. We want to keep the container very lightweight. We want to avoid writing all unnecessary files. And then again, when we run a Python application, the output is written to this standard error, standard out, etc. Right? Whereas we want it to be directly showed on the terminal. So here we are saying Python buffered equal to 1. So we want to buffer the output. Okay, but again, this is optional. So we did step 1, which is we built a small OS. Okay, a tiny OS. All right, and then we are creating a folder as working directory. And then here we are copying the requirements file, which contains all the dependencies, right? Requirements, where is it? Yeah, so the Python, Pydantic, FastAPI, we are using OpenAI, LLM, Agno frameworks for the agent, etc., right? So we copy that file, and then here we are installing all those dependencies. Okay, so from here, if you see, here we are installing all the libraries. Okay, that's the second step. And finally, we copy the code itself. So here we are copying the code and all other dependencies, like in this case, we are using local file as a database. So here we have the SQLite database. Now we are also copying the .env file for the credentials, but this is not the best way to do. Typically, we don't want to copy these env files across, but just keep it simple. The best way to do is while running the image, we can supply this .env file as a runtime variable. Okay, all right. So the third one is also done, and finally we tell it how to run our application. Okay, so the fourth step. All right. Now there are a couple of new concepts here. Again, I'll show you. Okay. All right. So what do we have? We have host, which is my Mac system. We have our app. We containerize the app. So we have a container. Okay. So we have 3 things: the host, from where we are running the code, and we containerize the application. Okay. So here we have 2 things. Now, how should these 2 be communicated with each other, right? So the host will have an address, app will have an address, container will have an address, things like that, right? So how should they be communicated with each other? So this command, the run command, will contain that piece of information. So with this one, what we are doing is, so the container, this container, it listens for requests on port 8080. So think of port like an address. So we are telling the container, hey, you listen for requests on your port 880. Okay, so that's what this command mean. And then, so here we have, so UVCon, that's the Python library to run this FastAPI application. And then here we have app:app. So app is our main app. So the file name is app. And within that one, our FastAPI application is also called app, right? You can have different names, but make sure the file name and then the app name matches with what we have here. So the first one should be the file name, the second one should be the actual app name. All right. Now, this one, we have another piece of information here, and we have another piece of information here. So what this does is, again, so our app by default, it listen for requests only on a specific port called 127.0.0.1, right? But with this, what we are telling the app is, hey, you listen or be accessible on all network interfaces so that you can accept the request I sent. Okay. Essentially, we are telling the app that wherever the request comes from, you accept it. Okay. That's what we are doing by specifying this host 0000. All right. And finally, this command, the port 880, so our app listen on container port 880. Okay. It's a little bit confusing, but just have this mental picture of the host, app, container, and how should they interact with each other, what's the address, which is what the port is. Okay. All right. Now, we still haven't tell how these two are related. That's when we run the Docker container. All right. So that's our Docker file. We keep the file in the same folder where we have the application, okay, so that we can access the requirement file and any other dependency files. And then all we need to do is commands. Okay, maybe I'll show you on the terminal. All right, so yeah. Show you remove. This is running. Yeah, so to build the Docker image, we just say Docker build and tmeans tag, we are giving it a name, my app. Okay, so dot means within the current folder. So it expects the Docker file within the folder. So by default, it look for the Docker file we just created and all our application code and any other files we have. So it simply execute all the broadly 4 commands, are actually only the 3. The last one is run when we actually run the application. Okay, so from here, if you see, so what happens is, so the first one, let's say the second one, and finally the third one. So this one is run when we actually run the application. Okay, so in the description, if you look at, so these first 3 sort of instructions, it executes. Okay, so all right, so here it is downloading this OS, this lightweight OS version, which hardly be a couple of 100 MB, and then it will install the required frameworks, libraries, etc., and it copy our application code. Okay, so it has created this Docker image and it named it as my app. Okay, because we tagged it as my app. All right, we build the image, and then in order to run it, all we need to do is just, okay, Docker run. Here is the command. Now here we again have this -p means port 880. So there are 2 port numbers, right? Now, so the second one belongs to the container. So we are telling the container, hey, you accept the request on port 880, right? And similarly, we have a host which also have a bunch of ports, right? By doing this, what we are saying is, hey, from my host, whenever I send a request to port 880, which is where, whenever I send a request using port 880, that should be mapped to the container port 880. Okay. Now this container port 880, this is defined in our Docker file. Now we can have any other port here, but make sure the host port are not being used for some other application. You can kill that and use it for this purpose, but it's a standard practice. We use this 880 or 8000. Okay. So from our host, using this port 880, we will be making requests. Okay. We will be sending the requests. And then the container receive our requests on port 880. Okay, again, these 2 numbers need not be the same. All right. Okay, so all right, so we run the container, and if everything is successful, we should be seeing that uvcon is running on HTTP 000.880. Okay, so all right, so what we can do now is go to this. All right, so this is the root. Display the message, the order tracking AI agent is up and running. So if you look at our code, so we just invoke the root. Okay, the root simply shows us this message, order tracking AI agent is up and running, right? But we want to invoke this endpoint, the chat endpoint, right? Now using this FastAPI Swagger docs, you can just do docs as I showed in the previous video, and then we can make a request from here. So let's just try out. So let's just say hi. So it should say, I'm helpful assistant. Would you like help with tracking your order? Blah, 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 blah. As you can see, something along those lines. And then you can say, yes, please. Let's give some order 2, 3, 4, 5. Hopefully we are not saying that's the order ID, but it's an agent. It's supposed to infer this as tracking ID and should give us the order status. Let's see if that's what happens. All right, that's exactly what happened. So here is our tracking ID, the customer name. We have the order ID and its expected delivery is on August 25th. Some other notes. Okay. Now, if you are used to Postman, which is a more of standard way of testing the APIs. So here we have the same endpoint 000880 and the endpoint name chat. It's a post request. The authorization, no auth. Okay. The headers, accept and content type, set both of them to application JSON, and your body is simply the message. Okay. So you just invoke it and you should see some message like this. All right. So going back, today we took our FastAI application and we containerized the application so that we can take it and deploy it on GCP AWS Azure quite easily, right? Without recreating the environment every time. All right. The reason we did that is because our application, in order to run the application, we need three things: the application code itself, the framework plus libraries, and the OS. Okay. So for various reasons, we package these three things together, and that's what is called containerizing the applications. And we looked at some Docker concepts, how to build the images, how to run them, and how to build Docker files, what are the essential components these Docker files contains, right? And then a few concepts on these ports, which is super important, okay? Because oftentimes we might have configured wrong ports, so we might be sending request from one, whereas the container accepting from some other, or maybe the app is not listening to all the ports, etc., right? So just make a mental model of our make a picture of how these things fit together, so that debugging, etc., becomes a lot easier. All right. So from the next video onwards, we simply take these container and deploy it on different services. Sometimes we don't use the containers. For example, we use the functions like AWS Lambda function or GCP Cloud Run functions, which doesn't use the Docker, which just which work as a short-lived function. Okay, so there we might use the FastAPI as it is, but it's a standard practice. We containerize the application and we deploy the containers. Okay, for all scaling, etc. purposes. That's all for this video. If you find it useful, please support and share in your network. Thank you very much.